Welcome to this lesson on air pollution, where we'll explore two critical atmospheric chemistry problems: smog and acid rain. These environmental issues affect millions of people worldwide, and understanding their chemistry is essential for developing effective solutions. Throughout this video, we'll examine how these pollutants form, their impacts on health and the environment, and the methods we can use to prevent them. Let's begin by understanding what smog actually is. Smog is a type of air pollution that forms from a mixture of smoke and fog. The term itself is a combination of these two words. Smoke plus fog equals smog. This term was first coined to describe the poor air quality problems that plagued urban areas, particularly during the Industrial Revolution. Smog reduces visibility and poses serious health risks to populations living in affected areas. There are two main types of smog, each with distinct characteristics. Classical smog, also known as London-type smog, occurs in cool and humid climates. It forms primarily from coal burning and contains a mixture of smoke, fog, sulfur dioxide, and particulate matter. In contrast, photochemical smog, also called Lowe's Angels-type smog, forms in warm and sunny conditions. This type results mainly from vehicle emissions and contains ozone, nitrogen oxides, and various organic compounds. The key difference is that photochemical smog requires sunlight for its formation, while classical smog does not. The formation of photochemical smog involves a series of chemical reactions driven by sunlight. In step 1, nitrogen dioxide molecules absorb sunlight energy and break apart into nitrogen monoxide and atomic oxygen. This process is called photolysis. In step 2, the atomic oxygen reacts with oxygen molecules in the air to form ozone. Finally, in step 3, the nitrogen monoxide can react with ozone to regenerate nitrogen dioxide and oxygen, completing the cycle. This continuous cycle produces high levels of ground-level ozone, which is harmful to human health and vegetation. Smog has numerous adverse effects on human health. It causes respiratory problems and makes breathing difficult, especially for people with pre-existing lung conditions. Smog irritates the eyes, causing redness, watering, and discomfort. It significantly aggravates asthma and allergic reactions, triggering attacks in sensitive individuals. Additionally, long-term exposure to smog has been linked to cardiovascular complications, including increased risk of heart attacks and strokes. Children, elderly people, and those with chronic health conditions are particularly vulnerable to these effects. Now let's turn our attention to acid rain. Acid rain is precipitation that has a pH less than 5.6. Normal rainwater is slightly acidic with a pH of approximately 5.6 due to dissolved carbon dioxide forming weak carbonic acid. However, acid rain is caused by atmospheric pollution from sulfur dioxide and nitrogen oxides, which make the precipitation significantly more acidic. This increased acidity can have devastating effects on ecosystems, buildings, and water bodies. Acid rain forms through specific chemical reactions in the atmosphere. Sulfuric acid formation occurs in two steps. First, sulfur dioxide reacts with oxygen to form sulfur trioxide. Then, sulfur trioxide combines with water vapor to produce sulfuric acid. Similarly, nitric acid forms when nitrogen dioxide reacts with oxygen and water vapor to produce nitric acid directly. These acids dissolve in cloud droplets and fall to Earth as acid rain. The sulfur dioxide and nitrogen oxides that cause acid rain primarily come from burning fossil fuels in power plants, factories, and vehicles. Acid rain has widespread environmental consequences. In forests, it damages leaves and depletes essential soil nutrients, weakening trees and making them vulnerable to disease. Aquatic ecosystems suffer greatly as acid rain acidifies lakes and rivers, harming fish and other aquatic organisms that cannot survive in low pH conditions. Historical buildings and monuments made of limestone and marble are corroded by acid rain, causing irreversible damage to our cultural heritage. Additionally, acid rain leaches essential minerals like calcium and magnesium from the soil, reducing soil fertility and affecting plant growth. Fortunately, there are several effective methods to prevent both smog and acid rain. Transitioning to clean energy sources like solar and wind power reduces the emission of pollutants from fossil fuel combustion. For vehicle control, using catalytic converters in cars and promoting electric vehicles significantly decreases nitrogen oxide emissions. Industrial emission reduction can be achieved by installing scrubbers in factory chimneys, which remove sulfur dioxide and other pollutants before they enter the atmosphere. Finally, afforestation, or planting more trees, helps absorb pollutants and naturally improve air quality. Combining these approaches can significantly reduce air pollution. To conclude, understanding atmospheric chemistry is crucial for addressing air pollution challenges. We've learned how smog and acid rain form through specific chemical reactions, their harmful effects on human health and the environment, and the prevention strategies available to us. By applying this knowledge and taking collective action, we can protect our environment and ensure cleaner air for future generations. Remember, every individual effort counts in the fight against air pollution.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.